Hello class, this begins our unit on sequences and series. We have basically two types of sequences and series. We have arithmetic and we have geometric. One is created by adding numbers and another one is created by multiplying. Now in this first lesson we are just going to look at the arithmetic sequences and the arithmetic sequences are created by adding numbers. So an example would be a set of numbers. Let's say we have 2, 7, 12, 17, and it is infinite, meaning it keeps on going. Okay? Well, you can tell that this is an arithmetic sequence because the common number that is being added in between each one is a +5. So in between each number, we are just adding 5 again. So you'd be able to tell what your next number is in the sequence by adding another 5 to the 17, and that would be the number 22. Okay, now, but what if it's not so easy as just being able to determine what the next number is? What if you're wanting to pick a number, later on in the sequence, maybe 100 times down? You're not going to want to add 5 each time, and so this is where we come up with a formula. Now, one thing I want to point out here is that if you cannot figure out just right off the bat what is being added each time, this number represents a common difference. Now we're going to assign a variable to this because we are going to use this in the formula in just a few minutes. So this is the common difference. Now we're going to call that just variable lowercase d. Okay? And if you can't figure out what this number is, all you have to do is pick a pair of numbers, so consecutive numbers, and you just want to go backwards, which means that you are going to subtract to figure out what is being added. Since this is with adding numbers, to go backwards, you would just subtract the numbers to figure out what this common difference is. Okay? Well, there is a formula that you can use when you're trying to figure out a certain number. Like if you're trying to find the 100th term, you're not going to want to add 5 every time, 100 times, to figure out what that number. It would be much easier if we had a formula. So we call this the explicit formula, and it is on your formula card that I gave you in class. The explicit formula is only used when you're trying to jump to a certain term. So, for example, let's say I have this example and they want me to find the 100th term of this sequence. -3, 3, 9, 15, and it keeps on going. Well, from your formula card, the explicit formula looks like this. A sub n equals a sub 1 plus d times n minus 1. Okay, so let's explain what these variables are. This a sub n, that represents the term number that you were trying to find. So for this example, it would be a sub 100, okay, that we're trying to find. A sub 1 is the first term, so the first term that you're given. D, of course, is the common difference. These are looking like C's. Let me erase that. It's not letting me erase it. All right, so let's just keep on going. And then N is just the number, the term number that you're trying to find. Whoops. Right. Okay, so let's use this formula on this example. So we are going to try to find the 100th term. So we're trying to find A sub 100 equals. Well, the first term is -3, so I'm going to plug in a -3 plus. Now we need to figure out what our D value is. Remember, D is just the common difference, or what is being added every single time. So from -3 to 3, from 3 to 9, from 9 to 15. Now I always choose, I try and choose two positive numbers. So if you look at the 3 and the 9, you can see that you're adding 6 each time, and then just check it with the other two to make sure. Yes, 9 plus 6 would be equal to 15, and -3 plus 6 would equal +3. So it does look like my common difference is 6. So I'm going to plug that into my formula, and then the N value that I'm going to use is 100. So 100 minus 1. Again, that's because I'm trying to find the 100th term. All right, so let's figure out what that would be. You can just type that into your calculator. So the 100th term would be the number 591. So let's look at another example. We have the sequence 31, 27, 23, 19. Now, when the sequence is going down, the numbers are getting smaller. Your common difference should be a negative number because you're adding a negative number to make it go down. So let's compare. If I look at 27 to 23, I went down 4. So it looks like the common difference is -4. Now let's check it. 31 minus 4, or plus a -4, would equal 27, and 23 plus a -4 would equal 19. So my common difference is -4. Okay, so let's try and find the 100th term. So let's use our formula. So we're going to do A sub 100 equals, the first term in my sequence is 31, plus the common difference, which is -4, parentheses, the number that I'm trying to find, which is the 100th term, so 100 minus 1. So type this into your calculator and let's see what you get. Hopefully you got the same thing that I did, which was -365. All right, I want you to try to do this next example on your own, so pause the video. Again, we're going to try and find the 100th term. All right, so let's check your answer. Hopefully you notice that a common mistake when they're all negatives is to think that if it's negative, it's continuing to go down. But if you notice from the -9 to -8.7, if you subtracted those numbers, you would see that it's going up by 0.3. Again, it's going up by 0.3. The negative numbers are getting smaller, so it is getting closer to the 0. So it's going up by 0.3. So that is your common difference. And then if you plug it into the formula, you should have gotten 20.7 for your 100th term. Okay, so the second thing I want to talk about is what's called the arithmetic mean. This is used anytime you're trying to find the middle term of an arithmetic sequence. Okay, so for example, if you have this partial sequence, so if they tell you that it's going to start with -18, and it's going to go on, and then the last number is -21. Now, again, it could keep on going after negative 21, but if they're wanting you, they want you to find the arithmetic mean of those two numbers, you've got the formula for it on your formula chart, and it's just to take the first number A and add to it the second number, or the two numbers that you're trying to find the mean for, and then you would just divide by 2. So I kind of think of this kind of like an average, but again, if it's an arithmetic mean, you're adding and then you divide by 2. Now for the geometric mean, it's going to be different. So if I was trying to find the mean for this, I would take negative 18, I would add to it the negative 21, and then I would divide by 2. So using my calculator, I would get negative 19.5 for the mean. Okay, so let's talk about the next formula that we're going to use in arithmetic sequences. This is called a recursive formula. What a recursive formula is used for is it is used for building a sequence. So, for example, if they give you one term of the sequence, then if you make a recursive formula, you would be able to use it to go ahead and build the rest of the sequence. Okay, so first we're going to talk about just how you set up the formula. From your formula card, again, you have two parts to the formula. Okay, so first off, you need to remember that you will always have two parts for this formula. First, you have your starting value. So whatever a sub 1 is, that's going to be your starting value. The second part of the formula is what you will use to build it. So it's a sub n equals, you want to use the previous term. So if we're talking about a sub n, the previous term would be a sub n minus 1. And then you're just going to add the common difference. Okay? So this is the formula, the recursive formula that you use in the arithmetic sequence. So let me just write down a few little hints. The a sub n is the next term. So in other words, you could say, okay, I'm going to find a sub 2. Well, that would be the term that you're trying to find, the next term. And then if you're trying to find a sub 2, you would use a sub n minus 1, which would be 2 minus 1, so it would be a sub 1. So it's basically the a sub n minus 1, that just represents the previous term in the sequence. And then, of course, d is just the common difference. Okay, so let's look at an example. Now, in this example, they're going to give you a sequence. So here's my sequence: 20, 30, 40, 50. And they want you to write the recursive formula. Okay, well, first off, you need to know what your D is. Going from one term to the next, I'm adding 10. So my common difference is 10. Now when you write your formula, the first thing you want to do is you want to write down what your first term is. My first term is 20. And then to find the a sub n formula, you would take the previous one, which would be just a sub n minus 1, and you would add the common difference. So we're just going to add in the difference for this sequence, which is 10. And this would be your your recursive formula. Okay? Now notice, this number and this number, those will be numbers always, but the others will just stay the variables. All right, so let's look at some examples that will be like the problems that you're going to do on your assignment. Example 1, they give you this sequence, -4, -1, 2, and 5. Now in all these examples, we're going to write both the explicit and the recursive formulas. So let's go ahead and start off with the explicit. All right, so the formula is, and this is from your formula card, a sub n equals a sub 1 plus d times n minus 1. Now I'm not trying to find a specific term, so my n value is going to stay n value in the formula. Now the first thing we want to write down is what our common difference is. So if you look from 2 to 5, it looks like I'm adding 3 each time. So check it. -1 to 2, I did add 3. -4 to -1, you added 3. So my common difference is 3. So let's go ahead and plug into the formula. A sub 1 is the beginning term, which is -4, plus the 3 times n minus 1. Now at this point, I do want you to clean this up. So go ahead and write it in the most simplest terms. So go ahead and multiply that 3 through. So you're going to have -4 plus 3n minus 3, and then go ahead and add together your like terms. So this is going to be 3n minus 7. That's what your a sub n formula is going to be. Okay, so your explicit formula always needs to be cleaned up. Now let's find our recursive. The recursive formula to start with, and this is from your formula chart, the first thing we're going to do is we're going to write down what our a sub 1 is. Our a sub 1 in this problem is -4. To get our a sub n, you would take the previous term, which is a sub n minus 1, and you would add to it the d, which is just 3. Now again, I'm just writing the generic form so that I could go ahead and keep building this sequence. So you're going to leave it just like this. Remember, the recursive formula has two parts. The a sub 1, what it equals, and then a sub n. Okay, this will never need cleaning up. Alright, for this last example, I want you to do it on your own. So I want you to write the explicit formula and the recursive formula using this sequence right here. Okay, and then I will have you fill in those answers on your whisk. See you in class.